Continuing with the second half of 11.2, and we're looking at the inverting amplifier circuit. First of all, circuit identification. RF provides a portion of the output back to the input, and this is in the form of negative feedback. So RF is one way of identifying a inverting amplifier. The input signal is applied to the inverting input, which results in the output being inverted. Circuit operation. Because the minus input remains at ground potential, 0 volts, it is referred to as and we've talked about this before, a virtual ground. Because of the feedback loop, voltage gain in an inverting amplifier is minus RF divided by R1. So the voltage gain is the minus indicates that it is inverted. Okay, again, we mentioned here RB's only purpose is to offset input, offsets current, and effectively no voltage drop, so we can ignore RB. The virtual ground concept. The difference between the inputs is 0 volts. Okay, difference between the inputs is 0 volts. Non-inverting input is at ground, so inverting input is virtually at ground. So since this can be ignored, and since we have the concept here of a connection between here and here, then the input is at what we would call a virtual ground. And so this voltage will appear across this vessel. We could calculate the current that will flow through here, and since no current flows into the op amp, that same current will flow through RF. And we can calculate the output voltage that way, and we will in just a moment. Since no current flows into the op amp, the same current flows through RF, just said that, and then here is our gain ratio. So let's calculate our gain. So we say that it's going to be RF over R1, and it will be minus. So in this case we have 56 divided by what, 2.7, and that will give us our gain relationship. So let's see if we can take a quick look at that. If we say 56 divided by, and it is 2.7 equals, and we have 20.741. So 20.741, that will be our gain ratio. Now again, we can calculate using Ohm's law, and in this case we could say 0.1 volt divided by 2.7 K will yield a current. That current will be felt through this component, and the voltage across this component will be our output. It won't be R1 plus RF, it will simply be RF because we have that virtual ground concept here, so our output will be from here to here. And so whatever that current is, we'll take that current times the value of RF, and we should get our output. So let's pull up our calculator again, and before we do this, why don't we look at, let's see, well we've got 20.741 on the screen. If we took that times the 0.1, that would yield 2.074 volts. Why don't we write that down? 2.074 volts. Now that is just the calculation based on the ratio of RF to R1 times the input voltage. Now if we did the Ohm's law calculation here, let's go in and say we have 0.1 volts as our input, and we're dividing that by 2.7 K, 2.7 exponent 3, and that would yield this current. And remember, that current will be felt through this through the 56K, so we would take that times 56 exponent 3, and there we have exactly the same value, 2.074 volts. And again, here is the same circuit. And just as a review, again, the A equaled RF over R1, and that was a negative value, and that was about it for that particular circuit. Then this is a simulation from Workbench, and let's see. This is a little bit different. This is the way it looks in Workbench. Here is our non-inverting input with RB there. Here is our inverting input coming in, and let's see. It is across here. We have RF is 47K, and the R1 is 3.9K, and our input is 25 millivolts. So why don't we pull up our calculator and quickly see what this would result in. So we have 47 divided by 3.9, and that will equal 12.051, and our input is 25 millivolts. We'll take that times 25 exponent minus 3, and that would give us 301 millivolts. Now this is a screenshot of the oscilloscope in Electronics Workbench, and I'm going to put a negative value right here, and what was that value? 301. Was it 301? I forgot to write it down. It was in fact 301.2 millivolts. And if we'll look on our screenshot here, the red value is the input, the blue is the output, and this yellow stripe here indicates the peak of the blue, and you'll notice here that it is 301 millivolts. That's exactly what we had calculated. And the red here is 24.988. That's very close to being the 25 millivolts that is applied to the input. So that is our output for our amplifier with the inverting input. Okay, I'm going to minimize this, and that concludes this section. Let's see, just quickly by review, we were looking at the inverting amp. We looked at the gain. Remember that the gain will be inverted. It also had that negative there, RF over R1. And we did the calculations. And that concludes section 11.2.